I've started by fixing the cylinder on the stretcher and the slide bars into the cylinder. Soldered joints, simple soldered joints, no great problems there. Next job is to solder on the motion support bracket. Let's check it's level. Do it both sides. There we go. Our next bit is slightly fraught with danger. What I'm going to do is solder the slide bar to the motion support bracket. Now I've tinned this already. I'm turning the iron down a little bit. What I don't want to is to interfere with the slide bar. So just a touch. Still nice and free. Push the crosshead slipper as far away from the soldered joint as possible because you're using low melt solder here and it will solder everything up solid. Whatever you do, don't get any solder contamination inside the slide bars. I speak from experience too many times. There we go. Next job is to fix the back motion support bracket to the stretcher. Make sure we put the radius rod on, again using low melt. I've tinned the back of the motion support bracket. That motion support bracket is white metal. This is a mixture of etched nickel silver and white metal. Just go on there. On the kit it all is in one piece. Now honestly, if you have to assemble all this valve gear in one go, it's a recipe for getting things wrong. It's dropped in nicely. Just check. It's a little bit up in the air, the front end. You can just adjust it slightly. You can see now why I leave this to the very last. Check against the body as well at various stages. See the reason for doing the valve gear last? Not just because it's difficult. Yep, that's not interfering anywhere. And then what we need to do is solder the radius rod to the back end of the motion support bracket. Nice satisfying fizz. The joint is made. Lop that off. On the real locomotives, this radius rod moved backwards and forwards. The degree of movement was dependent on how far the locomotive was linked up. By that I mean how far the valves were opened. If it were just starting, the valves are wide open, and this component would actually move backwards and forwards in tune with the combination lever and the union link. I've actually made that work on one or two occasions, but believe you me, it takes ages and ages. The kit isn't designed to do that, and on a layout you just do not notice. Right, there's no oil on that, shouldn't be any friction, and that this is also nice and smooth. We now come to finally anchor the eccentric rod onto the big end, the centre big end. What I've done is use little spacing washers. These are the Romford type, and also a little fibre washer, so that gets the connecting rod away from the coupling rod. And one thing I want to do is make sure that there's no way that the big end can be contaminated with solder. So that's a little fibre washer available from Romford markets, and that goes on there. That should protect the big end from solder. Further protection is the statutory paper washer, and then one more Romford brass washer. Now I'm leaving that clear because I want it to solder to the eccentric crank. LNER locomotives of this period, in fact most modern locomotives, had inside admission. What that means is, a visual means, is that the eccentric crank leans forward no matter which way the locomotive is running. Either side, it leans forward by about 20 degrees, something like that. So it's guesstimation really. Fix that on. We're going to solder it on. Don't want too much solder, just enough to secure it. Just check that. There should be a little bit of movement there. Notice too that the eccentric crank is set. That means to say bent ever so slightly away from the big end and itself. Otherwise it can cause problems. And then we just file this back. Just clean that out. Solder's flowed in very well. Just a little tug to make sure that it's not gone anywhere. Tear off the paper washer. What you don't want to leave is a great lump of paper. Now the advantage of leaving, if possible, the end of the armature on is you can turn this by hand, and you can see already that that's doing what it should do. No binding anywhere. I've now put the A2 back together, final bench test before dismantling again and eventually painting. And as you can see, the valve gear is nice and smooth. No clicking, no sticking, no jerking, just the way it ought to be. It is a simplified form, as I said. Real locomotives, more of the components moved, but to me that just complicates the matter. It depends how far you want to go. This will work on a very large system. In fact, it'll be on Stoke Summit's roster, so it's one of amongst 40 odd RA9 Pacifics, W1 V2 and so on, so it fits into that wide scheme. It's a layout loco.